Everyone. So in this video, we're going to briefly discuss the filtration pressures that are required for us to filter out our blood. So as you can see, this little equation at the top here, the goal is this. We want to have a positive pressure, meaning we want to be able to push the filtrate from inside of the arteries. Right, I'm going to draw over it in red here. We want to be able to push out the filtrate from inside out of the arteries. In other words, the glomerulus, which is the artery, we want the filtrate to exit the glomerulus and enter the capsule. I'm putting these red dots. We want them into the capsule. Why? Because once they're into the capsule, like we said before, this is where filtration happens. Now it's going to go into this tubule. I'm going to do it in blue now because in case you couldn't see it in red, we want it to go down here so it can continue through the process. So with that said, there's a couple factors here. So number one, the blood that's inside of the glomerulus has a certain osmotic pressure to it, right? So with that said, it's going to try to not leave. And in addition to that, we also have the capsule, right? So all the tissues in the blue area that I'm coloring in, all the fluid in here is pushing pushing into the glomerulus. So it's acting against us trying to get the filtrate out, right? So as you can tell, so again, if you're a little bit confused, what I'm trying to say is the fluids inside here are actively pushing into the glomerulus, preventing stuff from coming out, right? So because of that, these two pressures, the blood pressure inside as well as the glomerular fluid, they are pushing against the filtrate exiting. Right? We want the filtrate to exit. We want the filtrate to exit the glomerulus so we can filter it. So that means we need to make sure that we have a high enough pressure inside the glomerulus to exit. Right? So think of it this way. Let's go back to the refrigerator example. Right? I know it's not the greatest example in the world, but I liked it. Right? Let's say you have the refrigerator and you are going up a staircase. Right? So you're walking up a staircase and the refrigerator, you're trying to get the refrigerator to the top of the stairs. So you're trying to push this up the staircase. Well, the refrigerator is pushing back at you. The osmotic pressure and the glomerular capsule of what's around it is pushing your direction, right? It wants to go back down the stairs. But that's not what you want, right? You are the glomerular hydrostatic pressure. You are pushing the opposite direction. You want it to go up the stairs. So in this case, there's three outcomes. Outcome number one, both you and the refrigerator are pushing back at the same pressure. If that's the case, no one's moving, right? Option two, the refrigerator is pushing back onto you more than you push on it. If that's the case, you and the refrigerator are going down the stairs. The third option is the one we want. This is where you push harder than the refrigerator pushes you. The glomerulus needs to push harder than the hydrostatic forces pushing back on it. And that's how the filtrate is able to exit the glomerulus and enter that glomerular fluid. And therefore, it can enter the proximal convoluted tubule, which is this thing here I'm circling. And now it can go through the process of filtration. Here's a graph also showing how, as blood is pushed into the kidneys, it is going to continually decrease in pressure. So at the beginning, from the renal artery where it first enters the kidney, it has a pretty high pressure. And if you remember from our unit on the heart, our arteries are pushing blood all throughout our body and have a high pressure. That's why you can feel your arteries. That's why you can feel your blood pressure. That's why you can feel your heart rate. So you have a high blood pressure in your arteries. As they continue down the arterioles and then eventually to the capillaries, as we discussed before, the pressure is going to continually go down. And then as it comes back through the veins of the body, there is such a low pressure that you basically get to zero. So in this case, this is how we have the pressure needed to push the blood into the glomerulus and then have the filtrate exit the glomerulus. So at this time, if you have any questions, please let me know.